Let's talk about stock valuation. If I want to find the value of any financial asset, I need the present value of the expected future cash flows. So the value of any financial asset is the present value of the future expected cash flows. So I need to have an estimate for the size, the timing, and the risk of those cash flows. So those three important things: the size, timing, and risk of the cash flows. So if I want to value stock, I need the price of the stock today. So P0 is the price of the stock times 0. That's equal to what are the future cash flows for a stock? They're dividends. And we're going to assume that the dividends are paid at the end of each year. So I need an estimate of, not know, but I need an estimate of the dividend, D1, that's the dividend a year from now. Divide that by 1 plus K. Now pause for just a second. Remember the present value formula? Present value is equal to future value over 1 plus R to the T. This is the exact same formula, except I don't just have one future value. I have a future value in every year. So D2 over 1 plus K squared plus D3 over 1 plus K cubed plus, and this is going to go forever, right? D4 over 1 plus K to the fourth continues to go forever. So how in the world can I solve this? Because I have an infinite number of calculations to do. Well, let's take an example. Let's say that the dividend just paid is $2. And let's say we estimate K, and K takes into account the risk. We estimate K to be 12%. So I need to find a way to estimate these future dividends. So how can I do that? I'm going to say I think the dividends grow at a constant rate of 5%. So now what I have, P0 is equal to, D1 is 2 times 1 plus G. And pause right there for just a second. Well, let me put this, divide by 1.12 to the first. This is the future value equation. Future value equals present value times 1 plus R to the T. So I'm saying that the dividends grow at 5% every year. So D1 is D0 times 1 plus G. This is going to be, this is D1, right? D0 times 1 plus G is D1. Multiply by 1.05 again, or in other words, square it. And that's going to be D2 divided by 1.12 squared. And now all I have to do is do this an infinite number of times, which you can see here. Theoretically that works, but I can't do an infinite number of calculations. So what can I do? Let me move this up just a little bit. We can remember what we have here. I can say something like this. Let me move this up even further. I can say the price of a stock today is equal to D0, let me write it this way, D1 over 1 plus K plus D1 times 1 plus G over 1 plus K squared plus D1 times 1 plus G squared over 1 plus K cubed. This continues to go forever. So there's a mathematical trick. And I don't want you to concentrate too much on the algebra, but I want you to think of the intuition. The price of the stock is the present value of future cash flows. Now if I just do this, if I multiply times 1 plus K over 1 plus G, so multiply both sides times 1 plus K over 1 plus G, that's times D1 over 1 plus K plus D1 plus D1 times 1 plus G over 1 plus K squared, and I continue to do that forever. I'm going to leave a lot of this algebra to you to work out. If I take this 1 plus k over 1 plus g times p0 minus p0, what does that equal to? It's going to equal basically this term right here. Or excuse me, it's this term right here, the minus this term. So when I rearrange all this stuff, P0 is going to equal D1 over K minus G. That's the important thing. This is a non-constant, this is a constant growth model. P0 equals D1 over K minus G. Notice what we assumed, that the dividend to be paid was to be paid next year. In general, I can say the price of the stock at any year is equal to the dividend next year over K minus G. So what I can do now is I can say P0 is equal to D1 over K minus G. I know that D0, it's an ugly D, I know that D0 is equal to $2. That means D1 is equal to $2 times 1 plus G. Well, G was equal to 5%, right? So that's times 1.05. It's equal to $2.10. K was equal to 12%. So I can say this is equal to $2.10 divided by 0.12 minus 0.05. That's equal to $30. This is all assuming constant growth of the dividends. What if that's not a good assumption? What if we assume the following instead? We say, okay, the dividend today is still $2, same stock, the cost of equity or the discount rate is 12%, but what we assume now is it's going to grow really fast for 3 years. So for 3 years, call this GS for the short-term growth, is going to be 20%. Call this GL for the long-term growth, is going to be 5%. Okay, so now how can we approach this? Well, it's the same rule. The price of the stock is equal to the present value of the expected future cash flows. But now I just have to take more time to do this because I don't have constant growth that allows me to use the shortcut formula like this. I can't do that because I don't have constant growth. So what I have to do is this. I have this super fast growth for 3 years, D2 over 1 plus K squared plus D3 over 1 plus K cubed plus, so I have these 3 years of fast growth. Then I can sell a stock because it becomes constant growth at that period. So what I have here is, this is $2.40 divided by 1.12 plus $2.88 divided by 1.12 squared. So this goes up by 20% by 20% plus $3.456 over 1.12 cubed plus P3 over 1.12 cubed, and P3 is equal to D4 over K minus G, and D4 is equal to this number times 1.05, so that's 3.6288, which is this times 1.05 divided by K minus G. That's equal to 5184. So if I put that right here, I come up with $43.80. Okay, so that's the real quick mechanical version of stocks. Let me tell you a couple things here. First of all, to use this model, so if I want to use this model, three things have to be true. First of all, the stock has to pay a dividend. If it doesn't pay dividends, the dividend model doesn't work, and there are a lot of stocks that don't pay dividends. Secondly, the dividend policy has to reflect the financial health of the firm. So the dividend policy has to reflect the profitability of the firm. There are a lot of stocks that pay a penny dividend or a 2-penny dividend just to say they pay a dividend. I can't use this dividend discount model for them. 3, if I'm thinking about taking control of the firm, then this doesn't work. The main reason for this model is not to actually price stocks, because we're also assuming here that they pay a dividend exactly once a year and the next dividend comes in exactly a year. Well, that's not going to be true. For most firms, a lot of them pay semi-annually or quarterly, and rarely will it be exactly 1 year to the next dividend. But the main reason for this is for you to get the mechanics of how to value a stock, and that principle is the present value of the expected future cash flows. We're using dividends for cash flows here. It might be better in most cases to do something called free cash flow to the firm or free cash flow to equity. In those two cases, we can figure out the dividends that a stock could pay, not the dividends that it does pay. So that's a quick and dirty overview of stock pricing.